Section 5.2, Systems of Nonlinear Equations in Two Variables. What we will see that's different in this section than what was in 5.1 is that some of the equations will be nonlinear. Now we know a linear equation has a degree of 1 on the x and the y. The x and the y are to the first power. But we could have a circle, we might have a parabola, various other types of equations. So let's just think for a second. Let's say we had one equation was quadratic, so it would be a parabola, and one equation was a circle. And we learned in 5.1, even though we didn't actually graph, we learned that graphically the solutions are the points where the graphs intersect. So if we had this example here, there would be two intersection points. So that would be two ordered pairs that would be solutions. Okay, so let's look at what this slide says. A solution is still, like it was in 5.1, an ordered pair because we're just going to do two variables, x and y, that makes all the equations true. So that's the same as 5.1, has to make all the equations true. Now, these problems may have a solution set, which is the set of all such ordered pairs, meaning there could be more than one ordered pair that makes the system true. So we're actually going to use the same methods that we used in 5.1. So we'll start with the substitution method. And the first step is still the same as it was. Solve one of the equations for one variable in terms of the other. Now, you're still wanting to look for a variable with a coefficient of 1 or negative 1. That's the best variable to isolate. Now, some of these may have an x squared or a y squared in them, but we don't want to try to isolate a variable that has an exponent other than 1. That would require us to square root or cube root, and it would just make it much more complicated. So let's make a note here on step 1. Solve one of the equations for one variable in terms of the other. Choose a variable with coefficient of positive or negative 1 and exponent of 1. So you want the coefficient to be 1 or negative 1. You want the exponent to be a 1 on the variable that you isolate. So let's go ahead and look at our first example. So we've got two equations here in our system, and we're going to solve by substitution. So we're trying to pick a variable to isolate. Now, when we look at our first equation, we do have coefficients of 1, but we have exponents of 2, so we don't want to choose those. If I tried to isolate x here, I'd have to subtract the y squared. Let's just look at it real quick. I would subtract the y squared, don't write this down. And then to get x by itself, I'd square root both sides, and I'd have to do plus or minus square root of 5 minus y squared. And then I would have two different expressions there to substitute. So we do not want to isolate a variable that's squared. So that brings us to the second equation. We definitely need to isolate one of these, either x or y. Y has a coefficient of negative 1, so y is going to be the best choice to isolate. The second y is what we want to isolate. So before we do that, let's think about also graphically what we would be graphing if we did graph these two equations. The first one has an x squared and a y squared in it. If both variables are squared, that would be a circle. We studied those a while ago, so I don't know if you remember that, but this would be a circle. It would actually have center 0, 0, and the radius would be square root of 5. However, we're not going to graph these in this section, but I just want you to think about if we did graph it, it would be a circle. Now this one, has coefficients of 1 on both x and y, so it would graph as a line. So think about a circle and a line intersecting. Certainly possible that we could end up with two solutions here. Okay, so let's get back to our substitution method. We are going to solve for y. I'm going to start by subtracting the 3x. And since I left the y on the left, it's still negative, so then I need to divide by -1. And that gives us positive 3x minus 5. So whatever you get for y, you're going to substitute into your other equation. So this 3x minus 5 is going to go in place of this y. So we still need our x squared plus, and then in parentheses, you're going to put the 3x minus 5 squared equals 5. So the same equation, just replacing the y, so that now the equation only has x in it, and we can solve it for x. So to solve it, we would need to go ahead and multiply 3x minus 5 times 3x minus 5. We're going to FOIL that. And that would give us 9x squared minus 15x on the outside minus 15x on the inside, positive 25. And this is a quadratic because it has x squared in it. So I need it to be equal to 0. I'm going to go ahead and subtract the 5 that's over on the right to get my 0. Now let's combine like terms. So we've got 1x squared plus 9x squared would be 10x squared. Combine the x terms would be a negative 30x. And then 25 minus 5 is a positive 20. Now, I would always try factoring first, and you may notice right away that there's a GCF of 10, but rather than set that 10 out front, let's just go ahead and divide everything by 10. Remember, you can do that when you're solving an equation. So that's going to give us x squared minus 3x plus 2 equals 0. And then we'll factor that trinomial. It's going to be x and x. Factors of 2 that add to be 3 are 1 and 2. Same signs, both minus. Set those each equal to 0 is going to give us x equals 1 and x equals 2. So two x values. That means two ordered pairs. So in the end, we're going to write ordered pairs. We're going to have a 1 comma, and then we need a y value to go with it. And then we're going to have a 2 in the x, and we're going to need a y value to go with it. So that's what we're going to do next, find these y values. And we do it one at a time. And let's go back to this equation that already has the y isolated. So I'm going to start with x equals 1. Maybe we'll put in a different color now since we'll go purple. So I've found that x equals 1, and I'm going to plug it in here. Y would be 3 times 1 minus 5. So y is 3 minus 5, which is negative 2. So that's going to go here. When x is 1, y is negative 2. And then we're going to substitute in x equals 2. So that would be 3 times 2 minus 5, 6 minus 5, and y would be 1. So when x is 2, y is 1. We have two ordered pairs. It's a set, a solution set, and anytime you have a set, you're going to put these curly braces around your set. And that is how we express the answer to this problem. And certainly we could check the ordered pairs like we did in 5.1. You would have to check each ordered pair in each equation. Let me go ahead and show that at least once here. I'm going to erase to give us some room. So we'll start with the first ordered pair. Okay, so we are checking 1, -2. Now it has to make both equations true. So let's start with the first equation. We put 1 in for x, and we put -2 in for y. And let's see if that gives us 5. 1 squared would be 1. -2 squared would be 4. So 5 equals 5. True. Works for the first equation. Now we've got to check the second equation with the same ordered pair. So that would be 3 times 1 minus -2, and that should equal 5. That would be 3 minus negative becomes positive, and so we also get 5 equals 5. Therefore, we know that 1 -2 works. Then we would check the other ordered pair. Sorry, I don't have quite enough room here to get all this on the screen. Okay, we're going to check 2, 1. First equation would be 2 squared plus 1 squared should equal 5. 2 squared is 4, 1 squared is 1, and we get 5 equals 5. True. Okay, looking good. And then we check the second ordered pair in the second equation. And that's going to look like 3 times 2 minus 1 equals 5. 6 minus 1, and that is 5, so also true. Now we know 2, 1 is a correct solution, and that's how you would check it. Okay, so let's try another example. Still solving by substitution. So we have to start by picking which variable we are going to isolate. So I've got x, y over here. I've got x squared and y squared. We do not want to try to isolate one that's squared, as we saw on example 1. So that leaves me with either this x or y in the first equation. It really doesn't matter which one of those. I'm just going to pick y. So to isolate y, I would divide both sides by x. That would give me y by itself equals 4 over x. It is going to cause me to have a fraction, but that is actually better than having a plus or minus square root. So we'll go ahead and keep this. Y is a fraction. And then we're going to plug that into our y in the second equation. So that's going to look like this. X squared, we keep that. Plus, in place of y, we put 4 over x, and that's going to be squared, equals 8. Okay, so now it's got all x in it. We need to solve it. Let's go ahead and square the fraction. That's the first thing we need to do. When we square a fraction, we square the top, which would be 16, and we square the bottom, which would be x squared. Now this is actually a rational equation because it has a variable in the denominator. We want to get rid of that fraction by multiplying by the LCD. Since x squared is the only denominator, that is the LCD. So we're going to multiply every term by x squared. And let's write down the result of that. So x squared times x squared would be x to the 4th, plus, we're going to cancel those, so it'll just be a 16, and then we've got 8x squared. Let's go ahead and move that 8x squared over. So we've got our x to the 4th minus the 8x squared plus 16 equals 0. So we've got a trinomial. We're going to try to factor it. Now it's a little different than what we're used to. We usually have an x squared in front, but if you've got x to the 4th in front and an x squared in the middle, the only difference is instead of putting x and x, you're going to put an x squared and an x squared. so that when you multiply those, that's going to equal your x to the fourth. You're still going to look for numbers that multiply to be 16 and add to be 8, which are 4 and 4. Same signs, both minus. And so if we did FOIL that, the outside would be negative 4x squared, the inside would be negative 4x squared, and those would combine to be our negative 8x squared. So if you're not sure about the factoring, always go ahead and multiply, make sure the factoring works. And these will factor further. You have a difference of squares. So factors into x plus 2, x minus 2, each of them. So we'll go ahead and show all of that. And then set each factor equal to 0. And we have some of the same factors. We actually don't need to do it twice. I don't need to set x plus 2 equal to 0 twice. Just once is fine. And so we get x equals negative 2 and x equals positive 2. Now each of those has multiplicity too because they occur twice. However, the multiplicity, knowing that, is not needed here. That is needed when we are graphing, but in this problem, we don't need the multiplicity. Okay, so we ended up with 2 answers for x like we did on number 1, which means we're going to have 2 ordered pairs, one of them with a negative 2 for x, and one of them with a positive 2 for x. Let's go back to our equation that has the y isolated, and we'll change colors here and substitute. Let's start with x equals negative 2. Then y would be 4 divided by negative 2, which is negative 2. So when x is negative 2, y is negative 2. And then let's substitute in x equals positive 2. So it's y equals 4 divided by 2. Y equals positive 2, and that's going to go here. So those are the 2 ordered pairs. Put the braces around them because that's our solution set, and box that in. Certainly we could check them again. In fact, these are pretty easy to check in your head. Let's just look real quick at the first ordered pair. If I put it in equation 1, x times y would be negative 2 times negative 2, and that would equal our 4. So that works. And over here we're going to square negative 2. Squaring negative 2 would make 4 plus 4, and that would also be 8. So we can see that works. If we put in positive 2's for x and y, 2 times 2 is 4. 2 squared plus 2 squared would be 4 plus 4 is 8. So they both work. Okay, we are going to then move on to the addition method. Here we're going to write both equations in the form ax squared plus by squared equals c. In other words, we want the variables on one side, constant on the other, just like when we solved linear systems by addition. So let's go ahead, well, let's read step 2 and then we'll go to our first addition example. Step 2, if necessary, multiply either equation or both equations by appropriate numbers so that the sum of the x squared or the sum of the y squared coefficients is 0. So it's still the same concept as it was in 5.1. So here's our first addition example. So we've got an x squared in both equations. We've got a y squared and then a y minus 8 squared. But we do have variables on one side, constants on the other. So that's good. It's in the right form. Now, when we try to think about which variable we want to eliminate, we would definitely want to choose the x squared. If we chose the y, it would be very difficult because of the y minus 8 there. If it were just a plain old y squared, then y would be fine. But when it's got that expression with y squared, you don't really want to choose that one. So we are going to choose to eliminate x. We're going to eliminate x. So we need these x squareds to have opposite coefficients. So that means one of them needs to be negative. So I'm going to take this first one. That'll be easier than dealing with the y minus 8. And we're going to multiply it by a negative 1. And that result is going to be, I'm going to write it down here. Negative x squared minus y squared equals negative 5. And then we can add these two together and the x will be eliminated because x squared minus x squared is 0. Now we want to think about, okay, what are we going to do with this? Well, we can't really combine them when they're like that, so we're just going to write them side by side. So you're going to write y minus 8 squared minus y squared. So you're writing all of this down side by side since you cannot combine them. But you can add the 41 minus 5, and that's going to give us 36. Okay, so we're adding these two equations together, and this is the result. And that result has only y in it, one variable, so now we can solve it for y. Let's FOIL to get rid of those parentheses there. So we've got y minus 8 times y minus 8. Bring down the minus y squared and the 36. And if we FOIL, we get y squared minus 8y minus 8y, outside, inside. And last is positive 64. Bring down the minus y squared. And if we want to go and set it equal to 0, you could go ahead and subtract 36. And then combine all the like terms. So y squared minus y squared is 0. Negative 8y and negative 8y would be negative 16y. And 64 minus 36 is a positive 28. So it actually ended up linear because the y squareds canceled. So just solve the linear equation. We want to isolate the y, so we're going to subtract 28 and divide by negative 16. Negative divided by negative is going to make it positive, and we can divide the top and bottom by 4. So we get 7/4 for y. Okay, so once you get an answer for one variable, you're going to substitute back into one of your original equations. So I'm going to go into this first one here, and we're going to plug in, we'll change colors. We're going to plug in y equals 7/4. So it's going to look like x squared plus 7/4 squared equals 5. So to solve that, we need to square the 7/4. So we're going to square the top, square the bottom. And you have a fraction in it. Let's go ahead and clear the fraction out. So we're going to multiply everything by the denominator. So multiply by 16. And that is going to give us 16x squared. We're going to cancel those 16, so plus 49 equals 80. Now I've got an x squared, so it's quadratic, but these are both constants, so I could solve by square root method and try to isolate my x squared. That would probably be the best choice. So I'm going to subtract the 49, which is going to give me 31. I still want to keep isolating, so I'm going to divide by 16. So x squared is 31/16. Not a very nice number, but sometimes you're going to get fractions. It's okay. We square root both sides, so now we've got plus or minus square root of 31/16. Make sure you don't forget the plus minus. Well, 31 is not a perfect square, has no factors that are, but 16 is. So we would have square root of 31 over 4. Okay, now to write the solution set, we've got really two values of x. We've got positive square root of 31 over 4. So that's one ordered pair. And we've got a negative square root of 31 over 4. Now, both of those x's came from the same y. Y was 7/4. So 7/4 goes here and here. And so those are the two ordered pairs. Put the braces, and that's our answer. Now that one certainly would be a little harder to check. You could use your calculator to check. And we did end up with two solutions again. That won't always happen. It could be one, it could be two, it could be even 3 or 4 ordered pairs. So there's really no set number that you're going to have here. These actually, if we were graphing, would both be circles. First one's a circle with center 0, 0. Second one would be a circle with center 0, 8. Remember, your circle has the standard form x minus h squared plus y minus k squared equals r squared. So your center's hk would be 0, 8. Your radius would be square root of 41. And you don't have to know that for this particular section, but I just thought I would mention it as the final exam is coming up soon. It's good to review some of those things. Okay, let's see what we have next. I'm going to do another example of the addition method. So look at the first equation. We've got an x squared and a y. The second one, x squared and y squared. Well, we can't really eliminate y because they don't have the same coefficient. So we're going to have to eliminate x again. So eliminate x. And they're both positive 1x squared. One of them needs to be negative. So I'm going to go ahead and multiply my first equation by negative 1. And then we'll write that result down here below. So that's going to be a negative x squared, a positive 2y, and a negative 8. And then we're going to add these together. So x squared minus x squared, 0. Y squared and 2y cannot combine. It's kind of like the first example that we did of addition. You're just going to write them side by side, y squared plus 2y. Since they don't have the same exponent, they're not like terms, they cannot combine. But then over here we can do the constant. 16 minus 8 is 8. And so this is a quadratic equation. Let's set it equal to 0. Subtract the 8. And let's see if we can factor it. So we would have a y and a y. Factors of 8 that subtract to be 2 are 2 and 4. Different signs, larger positive. So a positive 4 and a negative 2. Set each of those to 0 is going to give us y equals 2 and y equals negative 4. All right, so we got two values of y. We need to substitute those back into one of the originals. I'm going to go into the first equation. I'm going to start with y equals 2. And we plug that in. So it's going to be x squared minus 2 times 2. Be x squared minus 4. And here we have an x squared constant. So let's do the square root method by isolating the x squared. So that means add the 4, which is 12. And now the x squared's by itself, so we can go ahead and square root. Do not forget the plus minus. And then we've got a radical here. We do not have a perfect square, but it does have a factor that's a perfect square. So that could factor into 4 times 3. And then we square root the 4, we're going to get 2 square root of 3. All right, so that's what we get when we plug in y equals 2. Now let's plug in y equals negative 4. So we've got x squared minus 2 times negative 4 equals 8. X squared, negative negative is going to make that plus 8. So, square root method again. Isolate your x squared. Let's subtract the 8. I don't know why it keeps doing that. Okay, minus 8 minus 8. And x squared equals 0. Square root both sides. Well, when you square root 0, you do not need a plus minus because 0 is neither positive nor negative, and the square root of 0 is just 0. So you're only going to get one answer for x when you plug in negative 4. So let's see what all of our solutions are. First, I have x equals plus or minus 2 square root of 3. So I'm going to start with the positive 2 square root of 3. And that came from y equals 2, so 2 is the y value there. Then I got x equals negative 2 square root of 3, and that also came from y equals 2, so y value 2. Then we got x equals 0, and that came from y equals negative 4. So we've got 3 ordered pairs to make up our solution set on this problem. And this would actually end up being a circle, this equation on the right, because both are squared. This one on the left, only the x is squared, the y is not. That would be a parabola. So let's think about that for a second. How could a circle and parabola intersect at 3 points? Well, it may be something like, here's our parabola, and it would have to basically the circle would have to touch the parabola in 3 places. And so you can think about different ways that you might be able to draw that circle in which 3 intersections could happen. It would be where you would have to have the circle intersecting the vertex. So let's see if I can draw that where you could see how that could happen. Something like, and that's certainly not a perfect circle, but it would have to be where the circle would intersect here and then here and here. So, again, you don't have to graph these, but just something to think about, that when you are solving these systems, there is a graph behind it that shows you why those solutions are what they are. Okay, so let's see the next problem. This one says, solve by the method of your choice. Now, sometimes you could use either method, but sometimes only one of those methods would really work. So let's think about this particular problem. I've got x and y in my first equation to the first power. Now in the second equation, I've got these expressions with x and y that are squared. So it would be really hard to eliminate one of the variables in this situation. But I do have a variable with a 1 coefficient and a 1 exponent, which means that substitution would be my choice for this particular problem. So let's go ahead and follow through with that. And we will start by isolating the y in the first equation. So that would involve subtracting the 2x. And it doesn't actually matter whether you write negative 2x plus 4 or 4 minus 2x. And that's going to substitute into the second equation. All right, so all of this is going into y in the second equation. So we're going to bring down the x plus 1 squared plus, we're replacing y with negative 2x plus 4. Now I still need the minus 2 that follows the y. Close squared and bring down the equals 4. Okay, let's go ahead. Inside these parentheses we have like terms. I'm going to go ahead and combine those next. So it's going to be negative 2x, and 4 minus 2 would be a positive 2. Now my equation has only x in it, so I'm going to solve this for x. I need to get rid of the parentheses, so I'm going to FOIL. So I'm going to go and write all that out. Got lots of terms here. And let's FOIL. So first, x squared. Outside 1x, inside 1x. If you need to write those out, that's fine, or you can go ahead and combine and make that a 2x if you would like. Last is 1. Bring down this plus sign, and then we FOIL again. Negative 2x times negative 2x is 4x squared. Outside negative 4x, inside negative 4x, last positive 4. And I'm going to go ahead and subtract the 4 that's on the right so that we have all this equal to 0, since it's a quadratic equation. Combine like terms. So x squared plus 4x squared is going to be 5x squared. See, these two will be 2x, and this will be a negative 8x. So 2x minus 8x, negative 6x. 4 minus 4 is 0, so then we've just got the plus 1 equals 0. Now we want to try to factor. This one has a 5 in front, no GCF, so let's factor if it is factorable by AC method. So we're going to do 5 times 1 would be 5. We need factors of 5 that add to be 6. Okay, well 5 and 1 will work, so now we know it will factor. Same signs, both minus. So we're going to rewrite this. Replace your middle term with minus 5x minus 1x. And now we can factor by grouping. So we're going to pull out a 5x and pull out a negative 1. And then we've got the x minus 1 in common. Pull it out. Leaves us 5x minus 1. And set each of those equal to 0. We get x equals 1. And if you need to work it out, let me go and work that out real quick. Add the 1 and divide by 5. So the other answer would be x equals 1/5. So we've got x equals 1 and x equals 1/5. So I know that's pretty involved, but it's all things that we've learned how to do. Just be very careful with all your calculations. And now we need to find y to go with those. So we're going to go back to our equation that has the y isolated. Remember, we can do that when we are solving by substitution. Addition, you have to go back to an original. All right, so I'm going to start with x equals 1. Then y is negative 2 times 1 plus 4. So negative 2 plus 4, y would be 2. When x is 1, y is 2. Now let's try x equals 1/5. So y is negative 2 times 1/5 plus 4. So that would be, this is like a 2 over 1, multiply across would make negative 2/5 plus 4. Let's make that a 4 over 1. And I'm going to go ahead and work this by getting a common denominator. If you prefer, you could multiply everything by 5 and clear the fraction out. Let's see, my LCD would be 5, so I'm going to multiply by 5 on that second fraction, top and bottom. Makes that 20 over 5. And negative 2 plus 20 is going to be 18. Keep the denominator. So when x is 1/5, y is 18/5. So let's see if we can write down our ordered pairs. Kind of running out of room here. We might be able to fit it in at the bottom. When x is 1, y is 2. When x is 1/5, y is 18/5. So we've got 2 ordered pairs. Put the braces on. And that is our solution set. Okay, so that brings us to the end of this lesson. I just did one video for section 5.2. Make sure you practice the homework problems and let me know if you have any questions.